Hello friends, grab your coffee, grab your cookie, and today, please keep both far away from any boiler room or water treatment skid because we are talking about oxygen. Not the good breathing kind, but dissolved oxygen in water that quietly destroys pipes, boilers, and heat exchangers while everyone is busy blaming something else. I am Michael Klepik, and for more than 15 years, I have been designing water and gas treatment systems for industrial plants, power generation, and process facilities. Today I want to explain what an oxygen deaerator does and why corrosion almost always starts here. What an oxygen deaerator really is. An oxygen deaerator is a water treatment system designed to remove dissolved oxygen and other non-condensable gases from water. In simple terms, first, oxygen is dissolved in incoming water. Second, water is heated and exposed to controlled conditions. Third, dissolved gases are released from the liquid. Fourth, oxygen is vented out of the system. Fifth, deaerated water leaves with much lower oxygen content. This is not filtration and not chemistry. This is controlled gas removal. Where oxygen deaerators are used. Oxygen deaerators are widely used in, first, boiler feedwater systems. Second, power plants and steam generation. Third, chemical processing facilities. Fourth, food and beverage plants. Fifth, district heating systems. Sixth, industrial heat exchangers. Seventh, any closed-loop water system where corrosion is unacceptable. If steel and hot water meet, deaeration matters. Why dissolved oxygen is so dangerous? Dissolved oxygen causes several serious problems. First, it accelerates corrosion of carbon steel. Second, it creates pitting corrosion that is hard to detect. Third, it damages boilers and heat exchangers. Fourth, it increases maintenance and downtime. Fifth, it shortens equipment life dramatically. Oxygen corrosion is silent, fast, and expensive. How the oxygen deaeration process works. The deaeration process relies on physical principles. First, water is heated close to saturation temperature. Second, gas solubility decreases as temperature increases. Third, oxygen and other gases are released from the water. Fourth, internal trays or packing increase contact surface. Fifth, released gases are vented safely. The hotter the water, the easier oxygen escapes. Behavior of oxygen inside the deaerator. Inside the deaerator, first, oxygen solubility drops sharply with temperature. Second, proper distribution is critical for efficiency. Third, steam quality affects gas removal performance. Fourth, poor venting allows oxygen to remain. Fifth, load changes affect removal efficiency. A deaerator looks simple, but it is very sensitive to design details. Torture oxygen deaerator technologies. Torture designs oxygen deaeration systems using several configurations. Tray-type deaerators. Used for high-efficiency boiler feed water treatment. Spray and tray combination deaerators. Used when wide flow variation exists. Vacuum deaeration systems. Used where heating is limited or steam is unavailable. Integrated deaerator plus polishing systems. Used when extremely low oxygen levels are required. A deaerator is always part of a larger water treatment strategy. Regulations and operational compliance oxygen control is driven by, first, boiler manufacturer requirements. Second, power plant operating standards. Third, corrosion control guidelines. Fourth, energy efficiency requirements. Fifth, long-term asset protection strategies. Deaeration is rarely optional. It is usually mandatory. Oxygen deaerator system design considerations. When I design a complete oxygen deaerator system, I always include, first, accurate temperature control to maximize oxygen release. Second, proper steam injection and distribution. Third, reliable venting of released gases. Fourth, corrosion-resistant internal materials. Fifth, instrumentation to monitor oxygen levels. Sixth, automatic controls to handle load changes. Seventh, easy access for inspection and maintenance. If any of these are missing, corrosion will find a way back in. An oxygen deaerator is one of the most important and most overlooked pieces of water treatment equipment. By removing dissolved oxygen, it protects boilers, piping, and heat exchangers, reduces corrosion, and saves enormous maintenance cost over time. I am Michael Klepik. Protect your water, protect your steel. And remember, corrosion does not announce itself, but deaeration stops it quietly. See you in the next video.